Good evening, students. Am I audible?
Yes, sir.
Okay. So we will get started with the next subtopic, that is motion of charges in electric and magnetic fields, right? So yesterday we already saw a concept where we calculated the force experienced by a charged particle when it is projected into a magnetic field. What was the value? It was Q into VB sine theta, right? So based on that, we calculated using the Fleming's left-hand rule, we calculated the direction and everything as well, right? Now, we will see what happens when a charged particle is projected perpendicular to the magnetic field. So what happens, guys? So let's say there is a magnetic field existing into the plane of the paper, and there is a charged particle which is projected perpendicular to the magnetic field into this region of B. So what will happen? F will be equal to QVB sine theta. So on applying this, what can you conclude? That the particle starts revolving in a circular orbit, and the radius of that circular orbit is going to be mv divided by qb, right? So the radius will be equal to mv divided by qb. So the frequency is going, so what is going to be the time period of the particle? Time period will be equal to 2 pi m divided by qb, and frequency is going to be equal to qb divided by 2 pi into m. Right. Similarly, if the charged particle is neither projected at an angle 0 degrees or 90 degrees with respect to the magnetic field, rather it is projected at some angle theta, then what is going to be the path traveled or the path in which the particle is going to traverse? Guys, we need a quick discussion on this. Only then we can concentrate on problems. I want you all to be active, please. I need immediate responses. So what happens when a charged particle is projected at an angle theta with respect to the magnetic field, where the value of theta is neither 0, 180 or 90 degrees? It follows a
Helical
helical,
path.
right? In that helical path, what is going to be the radius of the particle? It is going to be r is equal to mv into sine theta divided by qb, where theta is what? Theta is the angle between the velocity vector and the magnetic field vector, right? So what is going to be the time period? Time period is the same thing, 2 pi m divided by qb. So what is the important conclusion we can draw? So the time period of the particle, whether it is moving in a circular path or in a helical path, is going to be independent of the velocity with which it is projected. Am I right? Next, there is a extra concept with respect to the helical path, which we call it as pitch. So what is pitch actually? Pitch is the horizontal distance traveled by the charged particle for unit time period, right? So which is going to take the value of 2 pi into mv cos theta divided by q into b, right? Next is, what is going to be the kinetic energy gained by an electron when accelerated through a potential difference of v? So it is going to be something like this. Half mv square is equal to E into V. So what is going to be the value of V? It will be root of 2E into capital V divided by M. Right. So having this in mind, let's see how to solve this problem. So what is going to be the answer? An electron moving horizontally with a velocity of 4 into 10 power 4 meter per second enters a region of uniform. So velocity is 4 into 10 power 4 meter per second, enters a region of uniform magnetic field with a value of 10 power minus 5 Tesla, acting vertically downward as shown in the figure. Draw its trajectory and find out the time it takes to come out of the region of the electric field. So what is the answer and how to solve this? So theta is equal to how much? 90, and it is an electron. So indirectly the charge is given, which is 1.6 into 10 power minus 19 coulomb. So what is going to be the radius of the circular path? It is going to travel in a circular path. That part is clear because it is projected perpendicular. So R is equal to mv divided by q into b. So mass is 9.1 into 10 power minus 31 into v is 4 into 10 power 4 divided by q is going to be 1.6 into 10 power minus 19. into B is 10 power minus 5. Right. So what is going to be the answer? When you quickly calculate and tell me.
Sir, 225.
235. What?
No, sorry. 2.25 into 10 power minus
2.25 into 10 power
minus 2.
minus 2 meter per second. Is that right?
Sir, only meter.
No, it is meter. Radius, sorry. It is meter. Yeah. So it is going to be 2.25 into 10 power minus 2 meter. That is going to be the radius. But since in the question they asked, draw its trajectory and find out the time it takes to come out of the region of the magnetic field. So when it is going to come out of the region of the magnetic field, it should have completed how much distance?
Sir, 1/4 of the circumference.
See, actually, this is a circle. So out of that circle, it should cover a distance of pi r, no? Because it would have completed a semicircle and come out. So the time it takes to come out is going to be distance by speed. So the distance is going to be pi into r divided by the speed v. So pi into mv divided by qb divided by v. So this and this we get cancelled. Pi is 3.14. Or I can actually do one thing. In the place of r, I can substitute this 2.25. In the place of v, I can substitute this 4 into 10 power 4. Okay. Once you substitute and calculate, you will get the value of time. This is one of the kinds of problems which you generally don't find it in most of the CBSE questions. Okay. So make a note of this point. So whenever they ask you find the time it takes to come out of the region of the magnetic field, it should have completed half the circle because it is projected perpendicular. So it should complete a semicircle and then come out. So distance will be pi r divided by v. Divided by v is going to be 4 into 10 power 4. So because of this reason, I would say mark this question as important.
Sir.
Tell me.
Sir, if the electron were to enter in the magnetic field in the same plane, but like such that it is perpendicular to the direction of magnetic field, then it would be like
Come again.
pi by 4 only.
It is entering in which plane?
Sir, in the same plane as the magnetic field, but perpendicular to the pole.
How is that possible, right? So what is the plane in which this magnetic field is lying? I can't conclude the plane. No, see, they told it is acting in the downward direction. According to the question, if I take my hand to be the horizontal plane, the magnetic field is in the downward direction. So what plane you want to take it? So you're taking
if
the plane. Okay.
No, if now in this diagram itself, electron is entering. So now, if it if it experiences a force in the plane which is perpendicular in the same plane as that which electron entered in the first place, then like it only after covering 1/4 of the distance, it would be like the direction of magnetic field would be same as that of the direction of electron, right? So there would be no force, right?
But here it is not the same plane. No, see, visualize the diagram. If this is going to be the horizontal plane, this is the direction of magnetic field. So my right hand is the plane which contains the magnetic field. So this is acting vertically. So read the question, vertically downward, but the electron is moving horizontally. So where is there a possibility for the electron to come in the same line as force will be 0 only when there is a particular angle that becomes a 0 or a 180. In which case is it able to become 180 or 0? Read the question. Got it. So here horizontally and vertically plays an important role.
Okay.
So shall I proceed? So an electron travels in a circular path of radius 20 centimeter in magnetic field of this much value. Calculate.
Sir, in the before question, it will be like the trajectory.
This will be the trajectory.
Sir, won't it be in helical?
Helical varadra, because it is still projected perpendicular. Then I read the question carefully. Helical will come only when the angle is neither 0 nor 180 nor 90. 0 degree or 180 degree. See, these are all the 1 mark questions that they can ask. I want everybody to listen. So if they say a charged particle is projected in the direction of magnetic field or in the direction opposite to magnetic field, then what will be the path followed by it?
Circular path.
Listen to my question carefully. If a charged particle is projected in the direction of magnetic field or in the direction opposite to magnetic field, when I use the word in the direction, what is the angle?
0 degree, sir.
Zero.
When I use in the direction opposite,
180.
180.
180. So what is the force experienced by the particle? It is QVB sine theta. What is the
No
value of
force.
theta? So 0 degree or 180 degree. So what is going to be the force acting on the particle?
No force.
No force means should it not come to rest?
Yes, sir.
This is what we think, that is a mistake.
No, sir. Acceleration is 0, but it may be
Acceleration is
uniform
0.
velocity.
Yes. So this is a common mistake. When force comes out to be 0, many people assume that the particle will not move. Force 0 means acceleration is 0. So force can be 0 when the particle is moving with a uniform velocity also. Please make a note of this point. So what I'm trying to conclude here is, if a particle is projected at an angle, one minute. So when it is projected like that, acceleration is 0 means the object continues to move with uniform velocity, means it is going to continue to move in the same straight line path. Whereas if it is projected at 90 degrees, it will take a circular path. So what kind of a circular path is that? What kind of a circular motion is that? In circular motion itself, there are two kinds of motion. What are they? In circular motion itself, there are two kinds of motion. What are they? Uniform and non-uniform. So what kind of circular motion here are we speaking about? When it is projected at perpendicular, when it is projected at 90 degrees with respect to the magnetic field, what kind of? It is uniform circular motion. Means this particle is having acceleration only towards the center of it. It does not have any tangential acceleration. Whereas if theta is not equal to 0, 90 or 180, then what would have happened? That is when it will follow the helical path. I want this point to get registered because most of the questions asked will be from this topic. This is a very, very important topic, and there is a high possibility of you getting MCQs and assertion reason based questions from this particular topic. So is that clear?
Yes, sir.
So having this in mind, read the question carefully. An electron travels in a circular path of radius 20 centimeter in magnetic field. Even before you proceed, circular path and magnetic field, what should come to your mind?
Theta 90.
Perpendicular.
As 90. Calculate the speed of the electron. So R will be equal to mv divided by qb, which implies 20 into 10 power minus 2 is equal to mass of the particle is 9.1 into 10 power minus 31 into v is going to be how much? That's what we need to calculate. Divided by q is going to be 1.6 into 10 power minus 19 into v is going to be 2 into 10 power minus 3. So from this can we calculate v? So I'm approximating this to 6. It was 9.6 somewhere. So this will go 3 times. So V will be equal to 20 divided by 3 into 10 power 31 into 10 power minus 5. So 20 by 3 into 10 power 26 meter per second, which is going to be 6.67 into 10 power 26 meter per second. Why is it so? Did I miss anything? R is this much value, 20 into 10 power minus 6.67 is what they approximately wrote it as 7. So is it 7 into 10 power 20, 7 into 10 power 7? Oh, I forgot this 10 power 19, guys, sorry. Into 10 power minus 19. Here it is 10 power minus 19, it will be 10 power 7. Is the point clear? So whenever you have this mass of the electron to the charge, you can approximate it to, you can remember that value. Let me see what is the value. It's not calculated here. You can approximate it to 6. It will be 5.9 something, but you can approximate it to 6. So what is the potential difference through which an electron must be accelerated to acquire the speed? So V will be equal to square root of 2 into EV divided by M. How did we get this? Half mv square is equal to E into capital V. So which implies V will be equal to square root of 2 into capital V into V divided by M. So they are asking for the potential only, no? So potential is asked means I don't need all these things. Half mv square, I will equate it to E into V. Half mv square is equal to E into capital V, which implies capital V will be equal to half into M divided by E into V square. So M divided by E, I told you approximated to 6. So this will be 3. So 3 into V square. So 6.67 square into 10 power 7 square. Taking the approximate value, what should your answer be? 7 square will be 49. So 6.67, I'm saying, let's say it's 7. 7 square will be 49. 49 into 3 is going to be 27 to 147. So 147 into 10 power 14.
So 10 power minus 1.4 into 10 power minus 6.
No, 6.67. I took it as 7. 7 square is 49. No. So 49 will be 147 into 10 power 14. Into 10 power 3. Where did the 10 power 3 come from? Again, I made the same mistake. Here you have 10 power minus 31. Here you have 10 power minus 19. So don't forget that, okay? So M by E, we can actually have an approximate value. M by E is going to be equal to 9.1 into 10 power minus 31 divided by 1.6 into 10 power minus 19. So 9.1 divided by 1.6. Let's see. It is 5.68. Okay. Into 10 power minus 12. Remember this value. It is 5.68 into 10 power minus 12. Okay, I hope you understood. Shall I proceed? Try this. So in a chamber of uniform magnetic field of 8 Gauss, 1 Gauss is 10 power, Gauss is the CGS unit of magnetic field, is maintained. An electron with a speed of 4 into 10 power 6 meter per second enters the chamber in direction normal to the field. Describe the path of the electron. Without a doubt, it is circular. What is the frequency of revolution? It is QB divided by 2 pi m. What happens to the path of the electron if it progressively loses its energy due to the collision with the atoms or molecules in the environment? So what will happen? It will follow a spiral path, right? So when collisions are undergone, its energy is going to decrease. So what will happen due to its decrease in velocity, the radius will decrease. So when the radius is going to decrease, it starts moving in a spiral path. Are you able to understand what I'm saying? Guys, can I concentrate only on the content? Calculation part, I'm leaving it to you, okay? Can I?
Yes, sir.
Yeah. So we'll concentrate more on the discussion part. So this is what they told. Electron loses its speeds progressively. If after collision, its velocity vector remain in the same plane in the initial circular orbit, the radius of the circular orbit will decrease because R is directly proportional to V, right? So what will happen is the path of the particle will go in a helical path. Now do this. A proton is projected in a magnetic field of 0.02 Tesla.
So
Ah,
could you repeat what you said for the previous question?
which point should I say?
Sir, how does it travel in a helical?
Because during collision, what is going to happen? When collision is happening, kinetic energy will get converted to something else. Right. So it is not a perfectly elastic collision they are trained. So they told it loses its energy due to collision. So what energy is obviously lost? Kinetic energy. When kinetic energy is lost, velocity is decreased. When velocity is decreased, what will happen to the radius? Decrease. Means if a particle has started here, it will not be able to complete the same radius. Rather, it will complete a smaller radius. Means it will never be able to come back to its original point. So when the radius is going to decrease, what will be the path it is going to follow? That spiral path. It will be like that mosquito coil. That's what they are calling
Yes,
it as.
yes, sir. Got it, sir.
Yeah, this 0.02 travels in a helical path. So helical path means what should come to your mind? Theta is not equal to 0, 90 or 180, right? And helical path's radius is given as 5 centimeters. So 5 into 10 power minus 2 meter. Pitch is given as 20 centimeters. So 20 into 10 power minus 2 meter. Find the components of the velocity of the proton along the perpendicular to the magnetic field. Oh, sorry. Along and perpendicular to the magnetic field. So along the magnetic field, what is going to be the component? It will be V cos theta. I'm not sure how many of you remember this concept. I'll explain this. Listen. So if there is a uniform magnetic field existing, right? If a charged particle is projected at an angle theta like this, right, then V can be resolved into two components as V cos theta and V sin theta. Accepted? So this V cos theta is a component which is going to keep the particle in the direction of magnetic field. And V sin theta will be a component which will put the charged particle into a circular path. Accepted?
Yes, sir.
So the radius of the circular path is decided by the perpendicular component of the velocity. So R will be equal to mv sin theta divided by qb. So what they are asking is find the velocity of the proton along means they are asking what is the value of v sin theta and v cos theta. So v cos theta participates in the pitch. V sin theta participates in the radius.
Sir, along is only V cos theta.
That's what I'm saying. Well, listen to me carefully. V cos theta is along. V cos theta participates in pitch. I'm only talking about V cos theta or V sin theta. Either perpendicular, either horizontal, you have to decide. So pitch will be equal to 2 pi mv cos theta. So what is going to be pitch actually? Pitch is the horizontal component multiplied with the time period. So V cos theta kandupidikkanum. If you need to find V cos theta, that is a component along the direction of magnetic field. Which value are you supposed to use? You need to take the value of pitch. That's what they've given. Similarly, if you want to find the perpendicular component, that is V sin theta, they didn't ask you the angle. If you want V sin theta alone, you need to take the radius into consideration. Am I clear, guys? So from this, if you
Yes,
see, V sin theta will be equal to Q into B into R divided by M. So what is Q by M? I already told you Q by M is going to be, M by Q is 5.8 something. I told you, that number. What is it? 5.87.
68.
5.68 into 10 power minus 12 into what is the value of B? 0.02 upper 2 into 10 power minus 2. Can I take into radius is going to be 5 into 10 power minus 2. Can I take it like this? Am I right? So this is easy for you to calculate.
Sir,
Tell me.
sir, so V cos theta is responsible for translational motion. And V sin
Both
theta is
are
circular motion.
circular.
Yes,
Correct.
sir.
Correct. So this part, I hope you guys can calculate it, right? If I'm not wrong. Can you? See, as I mentioned at the beginning, right? I don't want to concentrate on calculation part. Can you do it? Anyways, when this
Yes.
material is going to come to you, you have the solution also available here. You can always cross-verify them later. Okay. So if this concept is clear, I'll proceed to the next one. I need a confirmation.
Yes, sir.
If there is any theory part that is disturbing you, please let me know. If there is anything from this. If anything is not clear, please let me know. If you're not able to speak, at least let me know in the chat box. I'll give you a minute time. If you want me to explain something, I'll do it.
Sir, can you tell orbital angular momentum? Formula?
It doesn't come here, don't worry about it. Angular momentum basically is mvr sin theta. So L is equal to mvr sin theta. But if the value of theta is 90 degree, L will be equal to m into v into r.
Okay.
Okay. See, yeah, since you asked this, right, one more thing that is striking my mind is there are these kind of questions also asked. I want you all to make a note of. So we saw that R is equal to mv divided by qb, right? So sometimes what they will do is, instead of giving you the charged particle, right, they will say, they'll give you 3 different particles and say that the linear momenta of all these particles is the same. Then find which one will have greater radii or radius. So what is happening here is this m into v is there, no? Can I replace it with p and qb? I leave it as it is. So where this p is called as?
Linear momentum.
So sometimes you can have questions based on this linear momentum also. Sometimes what they do is they give you the concept with respect to kinetic energy. So we know that kinetic energy is half mv square. So multiply and divide it with m. What will you get? Half into m square v square divided by m. So what is m square v square? It is
P
p
square.
So p square divided by 2m. So p will be equal to root of 2m into k. You can write it like this also. So r will be equal to root of 2m into k the whole divided by qb. This is another way of writing the same expression. So what you can say is, from this I can say r is directly proportional to root k provided q and b are the same. Q, B and M, all the 3 parameters are same. I can say r is directly proportional to root k. Are you able to understand? Similarly, kinetic energy can also be written as E into V, where E is the charge and V is the accelerating potential. So from this, I can write R is equal to root of 2m into, in the place of K, I can replace it with E into V divided by QB. This is another way of writing. Actually, instead of writing EV, right, I'll write it as Q into V. Because Q is the charge of the particle, V is the accelerating potential. Makes sense? Right? So you'll have these kind of questions also. Whether they ask in any exam or not, I will ask. Tell me.
Sir, is this accelerating potential or stopping potential?
Accelerating. Stopping comes only in the case of photoelectric effect.
Okay.
Sir, what is K, sir?
K is kinetic energy. Right?
Okay.
Am I clear with these all? Remember, I will definitely ask you in MCQs. You can expect these questions based on these concepts. I'll ask you what is the ratio of the momenta, or what is the ratio of kinetic energies when the radius is this. So you need to be strong with it. Is that clear?
Yes, sir.
Especially based on the concept which I told you yesterday: proton, electron, alpha particle, all these things. And also go through the concepts of isotopes of hydrogen also. These are all the concepts you need to go through. These are all the regularly asked questions. Unnecessary, don't lose mark. It is very simple. Okay. Shall I proceed?
Yes, sir.
Cyclotron is not there. Deleted. Next, I need to speak about the force. So one thing we saw is force experienced by a charged particle when it is projected through a magnetic field. The next concept that we are going to see is force experienced by a current carrying conductor when placed in external magnetic field. What is going to be the value?
ILB sin theta.
Perfect. So force will be equal to ILB sin theta. And maximum force will be equal to I into L into B, because maximum force will come into picture where the value of theta is equal to 90 degrees. Right. Having said this, let's try out some problems. So wire of length L carries a current carries a current I along the x-axis. Okay. The magnetic field of B naught into I cap plus J cap plus K cap Tesla exists in space. Find the magnitude of the magnetic force on the wire. So what is going to be the force, guys? It is I into, if I have to write it in vector form, it is L vector cross B vector. Am I right? So I is I only. Length of the conductor is L, but what should I write? L?
I cap.
I cap.
I cap. So since they told x-axis, by default, we'll take it as positive only. Okay, I cap cross B naught into I cap plus J cap plus K cap. So it will be B naught I into L into I cross I is going to be a 0. What is I cross J? So you can remember this.
K.
So you can remember the circle in the anti-clockwise direction. I cross J is going to be K. So I cross J is going to be K cap plus what is I cross K? So I cross K will be
Minus J.
so B naught I into L into K cap minus J cap. This is F vector, but they ask the magnitude. So magnitude will be how much? This value B naught I into L into square root of 1 square plus 1 square. So how much will be the answer? Root 2 B naught I into L. Is it clear?
Yes.
So this is going to be the magnitude. So write down this one. Try this one, sorry. The horizontal component of the Earth's magnetic field at a certain place. So BH is equal to 3 into 10 power minus 5 Tesla. And the direction of its field is from geographic south to the north. A very long straight conductor is carrying a steady current of I. What is the force per unit length on it when it is placed on a horizontal table, and the direction of current is from east to west, and secondly it is from south to north? Answer. So listen to this question, listen to this point carefully. Whenever the length of the conductor is finite, they'll ask you force. Whenever the length of the conductor is infinite, they'll ask you the force per unit length. Because the length of the conductor is not defined here. So what will be the value of F? F will be equal to BIL into sine theta. So in the case number 1, what is going to be the value of theta? It is going to be 90 degrees, which implies F will be equal to B is 3 into 10 power minus 5 into I into what is going to be the length of the conductor that we don't know into sine 90. So F by L will be equal to 3 into 10 power minus 5 I. Newton. What about this one?
Sir, Newton per meter won't it come?
Sorry, Newton per meter, sorry. Yeah, Newton per meter, assuming the length of the conductor is in terms of meter. Right? So I value is not given in the question, no? Adu I ampere, 1 ampere. I think it is 1. The current is 1 ampere. If the current is 1 ampere, it will be 3 into 10 power minus 5 Newton per meter. If theta is equal to 0 degree, sorry, when it is from south to north, theta is equal to 0 degree, force will be 0. That's it. Simple question, no?
Sir, for the first part, can we take as I cap, J cap?
Not necessary. Why do you want to take it?
Okay, sir.
Because they didn't ask you the direction, no?
Yes,
But if
sir.
you want me to solve it, I'll solve and show you. You want to know how it is. So when a horizontal table is taken, so this is going to be south to north, right?
Yes, sir.
So south to north, you can take it as minus
J
k
cap.
cap.
Okay.
I'm taking for the horizontal. It is away from me. Minus k cap.
Okay, sir.
And east to west, I will take it as minus I.
Okay, sir.
Then you remaining part you can solve it.
Yes, sir.
Shall I proceed? Do this. So current of 2 ampere enters at a corner A of a square frame of side 20 centimeter and leaves at the opposite corner C. Diagonally, it's a cube or square, no? So it leaves at the other end C. A magnetic field of 0.25 Tesla acts in the direction perpendicular to the plane of the paper. Find the magnitude and direction of the magnetic forces on the 4 sides of the frame. How do I do this?
Sir,
Hmm.
sir, I have a doubt.
Hmm.
Sir, here, since the current is in the same direction, will the length changes, sir, since it's ripple, right?
First of all, when the current is entering here, okay, at point A, what will happen?
Will divide into both.
It will divide into 2 equal parts. Of how much value? I by 2 and I by 2. Am I right? Did everyone do this? So at the point C, the downward I by 2 and the rightward I by 2 will get added so that I is coming out. Now take each conductor. Now Nitish, ask me your question.
Sir, will the side of the square will remain constant, sir, since
Okay.
light current will ripple, right? So it keeps on increasing.
Nothing will happen. Here, nothing is going to happen. Here, we're not changing the flux or something. No? Why would it change? You are saying this current and this current will repel or attract, whatever it is. Is that what you're asking?
Yes, sir. It should actually
Nothing.
repel.
It
No.
should attract. It is exactly opposite of charges. Like charges repel, currents in the same direction attract.
Okay, sir.
So what is going to be? So that will not happen here because there is already an external field. The concept of what you're asking will happen only when there are two parallel conductors and there is no field. Field generated to one conductor due to one conductor will actually affect the other conductor. That is why they are getting attracted or repelled. Here, the external field will not allow that to happen. Don't worry about it.
Okay, sir.
Yeah. Answer. What is the answer, guys? Force on the conductor AD, how much is it going to be? Why am I not having a response? BIL sine theta. What is the value of B? 0.25, which is 1/4 into I is how much? 1 into L is how much? 20. So 20 into 10 power minus 2 into sine theta is how much? 1. Cancel this. So it will be 5. So it is going to be 5 into 10 power minus 2 Newton. That will be the force on each conductor. But only thing is, force on AD will be in which direction? Will be downward. Force on BC will be leftward. Force on BC will be downward. Force on BA will be leftward. That's it. It's actually a simple question, no?
Sir, can you show the direction?
Use Fleming's left-hand rule. Yesterday I taught you, no? Forefinger, the direction of field. So field is upward. Central finger in the direction of current. So keep it like this. So forefinger, central finger, and extend your thumb. The thumb is pointing towards you.
Yes, sir.
This is the direction of this is the direction of field, and this is okay. So this is going to be the direction of field, right? So it will be like this. It will be in the downward direction. What I actually applied is, I applied I into L cross B. So from length, I curled my fingers towards magnetic field. So I need to curl my fingers in the upward direction. When I do that, it is towards me. So that's what I did.
Okay.
So this is where the concept which you mentioned starts. Force between parallel current carrying wires. So generally, instead of calculating the force, we will calculate the force per unit length between two parallel current carrying wires. And the value is given as, so if there are two wires where the currents are going to be I1 and I2, then the force acting between them is given as mu naught I1, I2 divided by 2 pi R or 2 pi D, where D is going to be the distance of separation between the two wires. So force per unit length will be equal to mu. So force per unit length is this value. Force will be equal to mu naught I1, I2 divided by 2 pi R into length of the conductor. That's it. Okay.
Yes, sir.
So current of 5 ampere So current of 5 ampere flows through each of the two parallel long wires. The wires are 2.5 centimeter apart. Calculate the force acting per unit length on each wire. So F will be equal to mu naught I1 I2 divided by 2 pi into R, where R is the distance of separation. So what is mu naught by 2 pi? It is 2 into 10 power minus 7 into what is the value of I1? I1 and I2, they both are same. So 25 divided by R is how much? 2.5. So this cancels this 10 times. So 20 into 10 power minus 7 Newton per meter is going to be the answer. Did you understand? Next comes the important question. What will be the nature of the force if both
Sir,
the
it is
currents...
2.5 centimeters.
Okay, then into 10 power minus 2. So how much will it be? It will be 10 power minus 5. So 20 into 10 power minus 5 Newton per meter. So what will be the nature of the force if both the currents flow in the same direction? Just now I told you. If currents are
They
flowing
attract.
they attract. So remember the concept exactly opposite to charges. Like charges repel, whereas conductors having the currents in the same direction attract. Similarly, when they are going to have currents in the opposite direction, they repel each other. Okay. Next, a long horizontal wire P carries a current of 50 ampere. It is rigidly fixed. Another fine wire Q is placed directly above and parallel to P. The weight of the wire Q is 0.075 Newton per meter and it carries a current of 25 ampere. Find the position of the wire Q from the wire P so that Q remains suspended due to the magnetic repulsion. So read the question carefully. There is a long horizontal wire which carries a current of 50 ampere and the name of the wire is P. There is another wire Q kept at the top, kept above P, and the weight of the wire is going to be how much? 0.075 Newton per meter. Actually, the weight of the wire per unit length. And it carries a current of 25 ampere. Now tell me, what should I take the direction of this 25 ampere to be? So since weight is acting downward, what do I need? I need a force exactly in the opposite direction to balance it. So to calculate this magnetic force, I need to say that the currents in both the conductors are in opposite direction. Only then P will be able to repel Q. Am I right?
Yes, sir.
So 1 minute. So keep trying this problem. Answer, guys. Mu naught I1 I2 divided by 2 pi R is going to be equal to weight of the object per unit length. So 2 into 10 power minus 7 into 50 into 25 divided by R is what we need to calculate is equal to 0.075, which is going to be 75 divided by 1000, which is going to be 75 divided by 1000. So this will go 3 times. R will be equal to 100. Oh, sorry, 1 minute. R will be equal to how much? 100 into 10 power minus 4 divided by 3. So that is 33.33 into 10 power minus 4 meter, or 3.33 millimeter. Got it?
Sir, how did we get L equal to 1000?
L is equal to 1000. L 1000 varlada. 0.075, I wrote it as 75 by 1000.
Oh, okay.
Yeah. I wrote it here, no, weight divided by L. Na?
Yes, sir.
So this is the value.
Okay. Sir.
Yeah. Shall I proceed? So this is not needed. So the next question is about the torques that are acting on the current carrying loops. So we know this concept, right? In electric field, we know that when a charge is placed in external electric field, what will happen to it? When an isolated charge is placed in external electric field, what does it experience?
Torque.
Force.
The isolated charge experiences force, dipole experiences torque. Similarly, when there is an external magnetic field, listen to this carefully. When there is an external magnetic field, if a current carrying conductor, if the current carrying conductor is placed in external magnetic field, it experiences force. Whereas if a current carrying loop is placed in external magnetic field, it experiences torque. That is why the topic is torques on current loops, and they will never say torque acting on the current carrying conductor. That is not right. Is the point getting registered in your mind? So torque on a current loop in a magnetic field is given as NIDA sin theta, where N stands for the number of turns, I stands for the current, B stands for the magnetic field, and A stands for the areal vector or area. And theta is going to be the angle between the magnetic field and the areal vector. Is that point clear? Now, this N into I into A can be collectively written as a term called as small m, right? That small m is called as the magnetic dipole moment. See, it's very simple. We know that torque is equal to P sin theta in the case of a dipole placed in external electric field, electric dipole and electric field. Similarly, when magnetic dipole is placed in magnetic field, it will be MB sin theta. Is the point clear? So torque vector will be equal to M vector cross B vector. So these are all the expression you're supposed to remember. So what is torque as a vector given as? It is given as M vector cross B vector. Okay.
Yes, sir.
So listen to this carefully. The maximum torque acting on a coil of effective area 0.04 meter square is 4 into 10 power minus 8 Newton meter. Even before you proceed, when you see the word maximum torque, what comes to your mind? Theta is equal to
90.
90. So torque is equal to MB. Right? Or I can write it as N into I into A multiplied with B. So what else is given? Area is 0.04 meter square, which I can write it as 4 into 10 power minus 2 meter square. Similarly, torque is given as 4 into 10 power minus 8 Newton meter. And the current is given as 100 into 10 power minus 6 ampere. Find the magnetic induction in which it is kept. Induction means the value of B. So torque is how much? 4 into 10 power minus 8 is equal to NS. There is only
1.
acting on a coil. Okay. So one more point, one more thing I wanted to mention is When they generally mention it as a coil, right, it will have n number of turns. When they mention it as a loop, it has one turn. But here, when they use the word coil, since they use the word effective area, it is considered to be of one turn only. So 1 into current is how much? 100 into 10 power minus 6 into area is how much? 4 into 10 power minus 2 into B is how much? That's what we need to find. So 4 and 4 are lost. B will be equal to
0.0.
0. 0.
0.
It is 10 power minus 2 basically, or 0.01 Tesla. Right. It's actually a simple problem. Right.
Sir, magnetic induction means magnetic field, right?
Because according to magnetism and its matter, magnetic induction is the same as the field that they are trying to talk about. Okay. So you can either mention it in Tesla or WB per meter square. What is WB?
Weber.
Weber per meter square. Weber per meter square is another unit of magnetic field. It's Tesla. So 1 minute time, do it fast and tell me. So N will be equal to 100. Length will be equal to 40 into 10 power minus 2 meter. Depth will be equal to 20 into 10 power minus 2 meter. Carrying it of 10 ampere. Placed at an angle 60 degrees with the magnetic field value 3 Tesla. So torque will be equal to NIAP 100 into IS 10 into AS 800 into 10 power minus 4 into T is going to be 3 into sine theta is going to be 3 by 2.
Sir, 12 root 3 into 10 power 3.
Sir, 1/2, sir.
Sine 60, which one? The sine 60 is root 3 by 2 only, no?
Sir, sine 30.
When placed making an angle theta. Okay, current carrying conductor is making an angle.
120 Newton meter.
How much?
120 Newton.
120, yeah. 120 Newton meter is correct. Actually, yes, it is not 12 root 3, right? Because see, when placed making an angle theta with the magnetic field means
90
current.
minus 60, sir.
Yes. So current is in the direction like this, and magnetic field is making an angle 60 degree. But what did I tell you? Angle is measured between whom? Magnetic field and the areal vector, not between the magnetic field and the length vector. So it is going to be 30. So sine 30 is supposed to be half. So how much is the answer? 120, no? 120 Newton meter. Yeah. So copy this question. Anybody with the answer?
Sir, the shape will be circle, right?
Sir, 49 pi on this side.
49 pi. So how much is 49 pi?
Sir, approximately 1.5, 150.
Correct. So what is the shape, guys?
Circle.
Correct. So shape should be circular, because what do we need? We need an area to calculate the torque. So among all the areas that are available with respect to a planar shape, circle takes the maximum area. So that is why you need to have circular value, because torque is directly proportional to area. So T is equal to NIAB sin theta. So how much is the answer? I'm not calculating. T is N.
Sir, 1.5 into 10 power minus.
Is it only one turn? So 1 into, let me write the expression alone. 10 into area is going to be pi r square. What is the value of r square?
0.4.
2 pi r should be equal to 44.
Sir, R is 7.
So r is 7 centimeter. So pi into r square. So 49 into 10 power minus 2 the whole square into b. What is the value of b? 100 into 10 power minus 4. So multiplying all these values, it's something 1.54 something you told, no? Into 10 power how much? 10 power?
Minus 3.
Minus 3 Newton meter.
Sir, the orientation will be along east to west.
That is magnetic field's direction. So east to west is the direction of magnetic field. You are creating a circular loop and placing it in the plane of the magnetic field so that the aerial vector of the circular coil is upward.
Yes, sir. So it should be in the direction of east to west.
Which one should be in the direction of east to west?
The coil.
Coil ke direction, it is only plane, no. Coil is a two-dimensional. It should be in the plane of the magnetic field.
Yes, sir.
Can you do this fast? So with this problem, actually, I thought I'll take till 7:20, but with this, we'll stop. Galvanometer is left out, which I'll take tomorrow. Okay. Apart from this, so I just wanted to know one thing. Can you guys let me know what are the topics with which you need help from this chapter? Is there any concept that is bothering you? Any conceptual clarity needed till whatever we discussed?
Sir, I have a doubt in example number 56, sir.
In this book, in the exercise that we did?
Yeah, sir, but in example number 56.
This one.
Yes, sir. So for east to west, why are we taking theta as 90, sir? Can you explain that one?
Because magnetic field is from south to north, no? Read the question. So in this case, what is theta? Theta is the angle between magnetic field and the direction of current. Current is from east to west. Magnetic field is from south to north. So what is the angle? Theta is 90, no?
Okay, sir.
Got it?
And then for south to north, it will be like 0, right?
0. Yes.
Okay, sir.
No, I'm not asking about this problems. I'm asking about the concepts. Is there any concept that you want me to explain? Because I was doing only problems. Any concept that is bothering you? Because I got few messages from people saying that the short videos are actually helping. Right? If that is the case, if you can tell me the subtopics which are bothering you, I can focus more on them. Nothing? Everything is clear? So what is the answer for this question? A circular coil of 25 turns and radius 6 centimeter carrying a current of 10 ampere is suspended vertically in uniform magnetic field of magnitude 1.2 Tesla. The field lines run horizontally in the plane of the coil. Calculate the force and torque on the coil due to the magnetic field. In which direction should the balancing torque be applied to prevent the coil from turning? So if the coil is like this.
Sir, 3.4.
3.4, I don't know. I think that is the answer. Yeah, 3.4. Correct. And next part of the question. So force acting on the coil is how much? This is a direct question. What is the force acting on the coil? Force is going to be zero. Because a dipole, magnetic dipole never experiences force. Torque is going to be NIAB sine theta. When you calculate that, you will get the answer as 3.4 Newton meter. In which direction should see? Since here the directions are not given, assuming the magnetic field to be in this direction and the current to be in the clockwise direction, what is going to be the direction of torque experienced by it?
Sir.
Mm-hmm.
Sir, UN says in the chat that his mic is not working due to penetrant.
Whose mic? My mic.
No, sir, his mic and
No,
he
sir,
messaged.
his mic is.
Mic is
Yes.
not working. Can anyone tell sir to see the chat? Okay. Is there any way you to see? Illada, videos cannot be watched in laptop. That is the only thing. You can, if you have a tab, you can watch there. Yeah. So here, magnetic field, if I assume it to be in the rightward direction and current to be in the clockwise direction, when the current is in the clockwise direction, aerial vector will be into the plane. So what will be the direction of torque experienced by it? It will be vertically upwards, right? So this is the torque experienced whose value is 3.4 Newton meter. So to balance it, you need to apply a torque in the opposite direction. Okay. Is that clear?
Sir, how can torque be vertically?
Calculate, no, that is how it works.
No, like, is it cross?
Which one is cross? The into
Torque
marker.
at the torque at the up region, is it cross?
This one.
Cross into mark. Into mark.
Into mark is the direction of the aerial vector.
No, sir. The torque at the upper region, is it into mark?
It is in the direction perpendicular to the magnetic field. See, if the coil is like this, if these fingers are the direction of magnetic field, coil is placed here. Okay. If the current in the coil is the clockwise direction, when I see it from the top, aerial vector is in the downward direction. Okay. So A vector cross B vector will be in the M vector cross B. Sorry, this is the direction of torque. This is 3.4 Newton meter. This is the counter torque. See, it's very simple, Ra. If you want, see, if you know the direction of current, if you want to find the direction of dipole moment, okay, listen. If the coil is in such a way that the current is in the clockwise direction, then what is the direction of magnetic dipole moment? It is into the plane. How did I find it out? Curl the fingers of your right hand in the direction of current and extend your thumb. So this into mark is actually the direction of magnetic dipole moment. So torque is calculated as the cross product between M vector and B vector. Am I right? So M vector in this case is minus K cap, cross B vector is in the direction of I cap. So K cross I.
Yes, sir. Understood.
Got it? Yeah.
Sir, but is there a case where the coil could spin on an axis where the diameter makes the axis?
Diameter makes the axis.
Yes, sir. If the diameter is an axis, can it spin around that axis? Like, is there a case?
So here, how is the torque acting? 1 minute. It's like this, no? I think in this scenario itself, it is going to revolve around the diameter only.
Sir, then this
No,
won't be
sir.
done.
How will it? Sir, how will it revolve around the
It
answer, sir?
revolve
It will
around
just
the
go down.
diameter. This is the diameter, na? It will go up and come down. See, anything can be a diameter. This is also a diameter. Not only this part, it can revolve around the horizontal, this part also. That is also a diameter.
Sir, but it's just going down now. How is it revolving?
So calculate the direction of force. It's not going down, Ra. That is a mistake. It is not force, it is torque. So listen to this carefully. You guys are getting confused. If this is there, okay, if this is the direction of current, at the topmost point, can I say that the direction of current is tangential in the direction of magnetic field? Can I say
Yes,
that?
sir.
Okay. Similarly, here at this point, can I say that the direction of current is in this way? Can I say it?
Yes, sir.
Now tell me what is the direction of force?
Sir, dot.
Upwards. Right here it is a
Yes, sir.
direction of force is a dot. Exactly on the opposite side, it will be into. So this upward force and this downward force together, is it not going putting the coil into rotation?
Yes, sir.
So where is it, about which axis is it revolving? It is revolving only about the diameter.
Yes, sir. Got it, sir.
You are getting confused with this torque. Torque is not causing the translatory motion, it is causing only the rotatory motion. Remember that. Okay. So whenever a trick to be remembered is whenever you want to find the direction in which the coil is revolving, always calculate the direction in which the coupled forces are acting. That will give you the answer. Okay. Okay. Is it clear? So shall we wind up?
Thank you, sir.
Thank you, sir.
Thank you, sir. Sir, sir, in the last question, sir, to find the direction of torque, area vector is not required. We are finding dipole direction and magnetic field is given.
Direction of dipole moment is the direction of aerial vector. Both are seen.
Okay, sir. Sir, here you assume it will be going downwards, no, sir. Is it because you found
Because nothing is
dipole?
given. Nothing is given. Had it
Can we
been
assume
given,
upwards also, sir?
then you should take the current in the anti-clockwise direction. Either make the
Okay, sir.
current clockwise or reverse the direction of magnetic field.
Okay, sir. Thank you, sir.
Yeah.